Hey everyone! I'm back with another impossible matchup that's been keeping me up at night. Tonight we're forcing a battle between Australia's biochemical assassin and America's desert tank, the Inland Taipan versus the Gila Monster. Now I know what you're thinking. Isn't this just going to be neurotoxic overkill? But here's what got me completely fascinated with this fight. The Gila Monster has a venom delivery system that's completely backwards from everything else we've covered. Instead of injecting and retreating, it bites down and chews venom into wounds for prolonged periods. Meanwhile, the Inland Taipan carries venom so potent, its lab-measured toxicity dwarfs all other snakes. But those fangs are only 3.5 to 6 millimeters long, designed for small, warm-blooded prey, not armored desert lizards. So what happens when precision neurotoxicity meets persistent grinding? When surgical strikes face mechanical endurance? By the end of this video, you'll understand why sometimes context matters more than raw potency. Inland Taipan. Let's start with our returning champion, the Inland Taipan. Up to 8 feet of slender death, weighing just a few kilograms. This thing is basically evolution's answer to the question, what if we made the perfect small mammal killer? In laboratory LD50 tests, Taipan venom ranks as the most toxic of any land snake, a lab measure of potency, not real-world lethality. With an average 44 milligram venom yield, that's theoretically lethal to 100,000 to 250,000 mice in controlled conditions. The active compound, taipoxin, is a presynaptic neurotoxin that literally stops nerve signals from reaching muscles. The delivery system involves strikes that occur in under 200 milliseconds, among the fastest recorded in snakes. And unlike pure strike and retreat hunters, Inland Taipans often hold prey briefly due to their fast-acting venom, ensuring effective delivery before release. Here's the critical detail. Those fangs are only 3.5 to 6 millimeters long and may struggle to reliably penetrate thick protective structures depending on strike location and angle. Here's what makes this snake fascinating behaviorally. Despite carrying the world's most potent land venom, taipans are intensely shy and reclusive. They live in remote parts of Australia, which is why human encounters are incredibly rare. This is the ultimate reluctant assassin, a precision weapon that would rather hide than fight. 3 Gila Monster Deep Dive. Now meet America's most misunderstood predator, the Gila Monster. Stocky, slow, and unmistakably ancient looking. We're talking about 18 to 22 inches of persistence, weighing 1.5 to 2.2 pounds on average, though the largest captive specimen reached 5.1 pounds, featuring bead-like scales with osteoderms, bone deposits within the skin that deter predators but don't form impenetrable plating. Here's where the venom story gets really interesting. No confirmed human deaths since 1939. Bites cause agony, but rarely deliver lethal doses. The venom contains a complex cocktail, including Heloderma, which causes catastrophic hypotension, plummeting blood pressure that could crash a high metabolism snake's circulatory system rapidly. But here's the medical plot twist. One component called Exendin 4 inspired the development of diabetes drugs like Byetta, highlighting venom's biochemical value beyond lethality. The delivery system uses grooved teeth in their lower jaw. They don't chew like mammals. Instead, they clamp down for 10 to 30 seconds, grinding laterally while forcing venom through grooves via capillary action. Duration varies based on threat level and the lizard's assessment of danger. This isn't a precision strike system. It's a biological vice grip. The lizard clamps down and forces venom in through pure persistence and jaw strength. Unlike snakes that inject and flee, the Gila's strategy is endurance and cumulative damage over time. And here's the behavioral twist. Despite being venomous, Gila monsters are actually quite docile. They spend most of their time underground in burrows, emerging mainly to forage for eggs and small animals. 4. The biological strategy analysis. This matchup is absolutely fascinating because we're comparing 2 completely different approaches to venom warfare, and both have evolved for totally different ecological niches. The Taipan represents what I call surgical neurotoxicity. Rapid strikes designed to shut down nervous and respiratory systems quickly. It's optimized for small, warm-blooded prey that could injure a delicate snake if given the chance to fight back. The Gila Monster uses mechanical persistence, slow grinding venom delivery that causes cumulative systemic effects over time. This makes perfect sense when you consider their Natural prey, bird eggs, nestlings, small mammals that can't effectively fight back during prolonged contact. But here's the critical question that determines this entire fight. Can the Taipan's short fangs penetrate the Gila Monster's osteoderms effectively enough for rapid neurotoxin delivery? And can the Gila Monster's slow, chewing approach work against an opponent designed for speed and escape? There's another factor: target biology and metabolism. Venom effects depend on target physiology. Neurotoxins optimized for mammals often act differently and sometimes slower in reptiles due to structural differences in receptor binding. Reptilian physiology can significantly delay the onset of neurotoxins compared to mammals, giving the lizard crucial extra time. Meanwhile, the Gila's venom cocktail could be devastating for a small, delicate snake with a fast-acting circulatory system. While untested, Gila monsters do show incomplete resistance to their own venom. They suffer local tissue damage but survive via slow metabolism. Their inherent resistance to beta neurotoxins from eating venomous prey may slow Taipan venom, but won't stop it entirely. Let's set up our impossible scenario: a drought-stripped canyon in the American Southwest. Climate change has pushed species into unfamiliar territories, and both predators converge on the same water source, one of the few remaining in this scorched landscape. Round 1. The strike analysis. The Taipan detects the large, slow-moving lizard and immediately prioritizes escape. Given its shy, reclusive nature, flight is always the first option. However, finding itself cornered with limited escape routes, it may resort to defensive strikes. The snake strikes targeting the lizard's head and neck area. Those fangs strike the Gila's armored back, achieving shallow penetration. However, a hit to the eyes or throat would be catastrophic, as these areas would allow full venom dose delivery. Round 2. The mechanical advantage. The Gila Monster's evolutionary strategy kicks in. Those powerful jaws clamp down with a bulldog grip, locking with approximately 50 newtons of force. Using lateral head shaking, it widens wounds while grinding laterally to force venom through grooves via capillary action. Rather than continuing aggressive engagement, the naturally reclusive Taipan would focus primarily on escape attempts. However, if held in that crushing grip, the Gila's grinding action works its Heloderma and other compounds into wounds while the snake struggles desperately to break free. The sustained contact represents exactly the scenario Taipans evolved to avoid. Round 3. The biological race. This becomes a complex race between different biological timers. Any neurotoxins that penetrated would work on the Gila Monster's nervous system, but reptilian physiology means effects could be delayed by 30 to 50% compared to the mammalian targets Taipan venom evolved for. The lizard's slow metabolism buys crucial time. Meanwhile, if the Gila achieves sustained contact, its venom delivery becomes devastating. The Heloderma causes catastrophic hypotension, and a Taipan's high metabolism body would crash rapidly under plummeting blood pressure. Even with some beta neurotoxin resistance, the Gila can survive long enough to inflict lethal envenomation through grinding persistence. The outcome in scientific analysis. In realistic scenarios, the most likely outcome would be the Taipan successfully escaping, given its speed and the Gila Monster's slow approach. However, in forced close-quarter encounters, where escape isn't possible, the Gila Monster holds a significant advantage, likely prevailing in the majority of these encounters, but only if it avoids a perfect Taipan strike to vulnerable areas. While the Inland Taipan's venom is 100 times more potent in lab tests in mice, the Gila Monster's biology flips the script. Osteoderms reduce effective envenomation in most strike locations. Reptilian physiology can significantly delay neurotoxin onset, and the Gila's crushing bite forces venom deep over time. The Taipan would only achieve victory with a perfect strike to the eyes, mouth, or throat, areas where fangs can deliver full venom dose and then successfully escape before being clamped. This represents a low probability outcome in forced encounters. Meanwhile, the Gila Monster's mechanical persistence, combined with the combination of deep tissue trauma and venom seepage, proves devastatingly effective. Even with neurotoxins in its system, the lizard's slow metabolism allows sufficient time to inflict lethal damage via grinding. This isn't a flaw in the Taipan's design. It's proof that evolution crafts specialists, not universal champions. The world's most potent land venom means nothing if it can't be delivered effectively to the right target, in the right place, at the right depth. Real-world effects depend on dose, delivery location, and victim physiology, lab LD50 values, don't directly translate to combat outcomes. Sometimes the weaker weapon wins through superior delivery and biological mismatch. The most honest conclusion? In nature, these species would never interact, having evolved for completely different environments and prey. This hypothetical matchup reveals more about evolutionary biology than actual combat prowess. What do you think about this biological arms race? And what impossible matchup should we analyze next? Drop your thoughts below, and let me know what evolutionary showdown you want to see dissected. I'm always hunting for the next biological puzzle that reveals how evolution shapes survival strategies.